Hi everyone. So today we're looking at lesson 6.3, and this is about solving more systems of equations. And the learning target that we're going to focus on says I can write a system of equations to represent a problem scenario to be able to solve algebraically using linear combinations. So linear combinations is another method to solving for a system of equations. And essentially, when we think about linear combinations, we do that elimination method that we talked about in class. So let's look at problem number 2, and it's called You're My Best Buddy. And we're talking about making friendship bracelets for the school spirit club. So I'm not going to read you the whole problem, but I'm going to jot down some notes so that you kind of know the scenario and you have them in your notebook. So the School Spirit Club is making friendship bracelets. They're going to come in 2 sizes, 5 inches and 7 inches. Now, note that when I write the quantity 2, I wrote it as a word. That's because 2 is not a value relevant to our problem. It's a descriptor. We know that we have enough beads to make 84 bracelets total. And so far, we've made 49 bracelets, which is about half the number of 5-inch bracelets we're going to make and 3/4 the number of 7-inch bracelets we're going to make. And obviously, the question is, how many of each type of bracelet can we make? Now, you're probably looking at the fractions and getting a little concerned. That's why I chose this problem to demo for you, so that you would have a good example of how to utilize, actually something you probably haven't heard in a long time, the least common denominator in order to solve for a system of equations. So part 1 says write an equation in standard form. And this equation is going to describe the total number of bracelets we can sell. Now, the information that we've been given says that we can make 84 bracelets, and presumably they're going to be made up of a combination of 5-inch bracelets and 7-inch bracelets. However, we're not sure how many of each, so we're going to set x is equal to the number of 5-inch bracelets, y is equal to the number of 7-inch bracelets, and we're going to write our first equation, which is x plus y equals 84. That should be straightforward enough. Step 2 says write an equation for the number of bracelets that are already made. So if we look back in our notes, there are 49 bracelets already made, and that represents about half of the number of 5-inch bracelets that we're going to make, so half of our x quantity, and 3/4 of the 7-inch bracelets we're going to make, so 3/4 of our y quantity. Sorry about that. Make sure you get that equation down. There we go. So that's the second equation in our system. Step 3 says to write the system of equations. Now, the notation for writing a system is just to put that one left-handed bracket and then to write both equations in standard form. Standard form just is ax plus by equals c. So we have a coefficient in front of the x and the y, a constant as our value on the other side of the equal sign. That helps us to line up all the pieces of our equation, right? Part 4 mentions that Karen says the first step to solve this problem would be to multiply the second equation by the least common denominator of the fractions. Now, this is something that we may be thinking, is this right? Is it not right? So the least common denominator of 1/2 and 3/4 is actually 4. So if I went ahead and multiplied that second equation by the quantity 4, 1/2 times 4 is 4/2 x plus 12/4 y is equal to 196. I'm going to simplify those fractions. 2x plus 3y equals 196. And this is the equation that I'm going to use to go ahead and solve my system. So now I have two equations with whole number coefficients. I'm going to multiply the first equation by -2 so that my coefficients of my x's are opposite values, so they will cancel out. I'm going to add my y coefficient, so -2 plus 3 gives me +1. -168 plus 196 gives me a value y equals 28. If I plug that back into my very first function, I get x is equal to 56 and a solution of the coordinate 56, 28. Now let's just be mindful of why that worked. The least common denominator of 2 and 4 was 4. And so I was able to simplify my fractions into whole numbers. And then I was able to use that linear combinations or elimination method to eliminate my x variables. When I solved for y, I had a coefficient of 1, so I just got a value of y equals 28. Substituted that back into my original equation, and I was good to go. Now you always want to make sure you plug that coordinate back into your original functions to confirm you're correct.